Hello everyone, welcome to K Diagnostics, Dio here. Today we have a 2005 Chevrolet Silverado with a 4.8 liter. The complaint on this truck is that the check engine light remains on while the engine is running. So the first thing we're going to do is we're going to confirm the customer's complaint. After confirming the customer's complaint, we're going to connect the scan tool to the truck to see what kind of trouble codes we have in memory. So now let's confirm the customer's complaint. Alright guys, so now I'm gonna start the engine so we can confirm the customer's complaint. So right there, as you can see, the engine is running and the check engine light remained on. So customer's complaint confirmed. So now I'm gonna connect the scan tool to the truck to see what kind of trouble codes we have in memory. So I'll get the scan tool connected and then I'll bring you guys back up once I get the scan tool connected. Alright guys, so I got the scan tool connected to the vehicle and here are the trouble codes that we have in memory. P0300, engine misfire detected, and the other code is P0442, EVAP system small leak detected. So these two trouble codes are causing the check engine light to remain on. Okay, so this P0300 trouble code is because we have cylinders that are misfiring. It could be all the cylinders or it could be one or two. So, and then this one is because there's a leak in the EVAP system. So these trouble codes are pretty self-explanatory. An EVAP system is a system that routes fuel vapors from the tank to the engine so that these vapors or hydrocarbons can be burnt while the engine is running, because we don't want vehicles putting out hydrocarbons to pollute the air. Okay, so the EVAP system, when I usually have EVAP codes, especially this P0442, what I find is most likely the cause is either a gas cap. I mean, it says small leak detected. So if you have a gas cap that's worn out, the seal on the gas cap, if the seal is no longer sealing the gas cap to the filler neck on the fuel tank, this will cause this trouble code to come up. And you can also have a sticking vent solenoid that can cause this, or a sticking purge valve. A sticking purge valve can also cause this trouble code to come up. So now what I need to do is I want to back out of here and look at freeze frame data. I want to see what the computer was looking at, or what kind of data the computer was receiving when this trouble code set. So I want to know if this, especially this P0300 code, I want to know if this P0300 code set when the engine was hot or when the engine was cold. Okay, that will dictate how I'm gonna go about fixing this. And also we will do a EVAP seal system test with the scan tool to see if this is a small leak or a large leak, and then we will go check the gas cap, or we can also use a smoke machine. That's probably going to be the easiest. We can use a smoke machine to see where the leak is. So let's back out of here. So we're going to go to freeze frame / failure records. So right here. So let's look at the freeze frame of this trouble code first, the P0300 code. So here I'm interested in engine speed, engine temperature, and maybe vehicle speed also, and fuel trim numbers. So right over here, our engine temperature, when this trouble code set, our engine temperature was 204 degrees Fahrenheit. So at operating temperature. And then our engine speed was 1687 RPMs, not degrees. And then our vehicle speed, so right here, the vehicle speed was 60 miles per hour. And then our fuel trim numbers, so right here, bank 2, short term was -3, and then long term was +4. So this is bank 2. What about bank 1? So our fuel trim numbers were within the plus or minus 10% range. So our fuel trim numbers are good. So, I mean, this vehicle may just need a tune-up. I mean, spark plugs, and I think this has wires too. So this vehicle may just need spark plugs and spark plug wires. So now let's look at So now we're gonna look at some misfire data to see if there's any specific cylinder that's misfiring. So let's go to misfire data. We're gonna look at the history data first, and then, so right here, history, it looks like cylinder 2's got some counts, cylinder 4, cylinder 6, cylinder 8, and then what about the other ones? So one has got the most counts, 3, 5, 7. So basically all the cylinders are misfiring. To deal with this code, the first thing I want to do is I want to do a relative compression test on this vehicle, because I mean this is a pretty old truck and it has a lot of miles. So we could have an engine that's not working right mechanically. So a compression test will tell us how well an engine is working mechanically. Actually, let's start the engine to see if there's a cylinder, or let's see if the cylinders will start misfiring now. I mean, the engine is fairly cold because the freeze frame told us that these cylinders were misfiring while the engine was hot. So it looks like cylinder 8 is starting to count. It's right there. 2 is not counting, 4 is not counting, 6 is not. So 8 just went down to 0. What about the other ones? The other ones are not counting. Yes, I mean the engine is cold right now. So our fuel trim numbers were not bad. So I'm gonna look at, I can pull out one spark plug just to look at it, or we can also use our lab scope to do a relative compression test on this vehicle, just to make sure that this engine is working fine mechanically. I mean, I just have a feeling that this is just gonna need spark plugs. So let's back out of here. Let's go to engine data and let's look at fuel trim numbers. Long term on bank 1 is 5, and then our long term on bank 2 is 13%, and our short term on bank 1 is 2, and then our short term on bank 2 is 1. So our trim numbers are basically within spec. I mean, I don't like how this long term number is over 10%. I mean, this is 13% is a little high, you know, on the long term here on bank 2, but nothing really concerning or nothing like too bad right now. And usually when you have high positive numbers on the long term and the short term, it means you have a problem in the fuel injection system. And if you have high negative problems, it means you have a problem in your ignition system. So, and this is, I mean, I use fuel trim numbers quite often when I'm diagnosing misfire concerns. And right now our fuel trim numbers are not really concerning. So let's back out of here. And what I want to do is I'm gonna take care of this P0442 trouble code first, because I think this is gonna be the easiest. Let's start with this and then we'll come back to the P0300 code. Okay. All right, so let's go to functional test and let's go to output controls. So we're gonna do a EVAP purge/seal test. Okay, so this will basically close the vent solenoid, and then it's gonna allow us to toggle or open momentarily the purge solenoid, and then we're gonna close it to see how long the EVAP system is gonna hold vacuum. Okay, all right, so here it says purge controls the purge solenoid and closes the vent solenoid. Seal commands the purge. Yeah, so we know what that means. It's just basically explaining to us how this test is gonna work. Okay, so it gave us a list of all these data pages, so we're gonna customize this list. What I want to look at is, so let's deselect all. So I just want to look at the EVAP purge percentage. I want to look at the vent solenoid, the fuel tank pressure, the fuel tank pressure sensor data pid, the fuel tank pressure voltage. That's all I want to look at for this test. Okay, so basically let's graph the fuel tank pressure data pid. So as you can see right now, at this point the vent solenoid is not venting. Okay, the vent solenoid is closed, and the purge valve or the purge solenoid is also closed. It's at 0%. Okay, so purge solenoid is at 0%, completely closed, and vent solenoid is also closed. So right now we should just have atmospheric pressure in the EVAP system. Okay, so right now, as you can see, we're reading 0.13 inches of mercury. So once I open the purge valve, this atmospheric pressure should drop. It should drop to vacuum. So we're gonna open it slowly. Let's go up to 20% right there. So I'm opening the purge valve. So we're reading 20% right now on the purge valve, and we're still not venting. As you can see, our number here, the fuel tank pressure sensor did not change. Well, it's changed a little bit. It took a little while. So now it's starting to change. Okay. And you saw how it took a little longer. And this could be caused by a sticking EVAP purge solenoid. Okay. So now we're reading basically vacuum. You see how we're reading negative 6. Okay. So right there, let's go up to 10. So now we're gonna go down and close this. So I just closed the purge valve, and let's see how long this is gonna hold vacuum. So right now there's vacuum in the EVAP system. Now let's see how long this is gonna hold it. I mean, this is definitely a very small leak, because usually when you have a large leak, it will just come back up to atmospheric pressure. And as you can see, I mean, it's going back up, but it's very slow though. So right here. So what we just did is we opened the purge valve, we allowed vacuum to enter the EVAP system, and now we just closed it. There's vacuum in the EVAP system right now, and it seems to be holding it. I mean, although it's going up pretty fast, but it's kind of holding it. So it's a very small leak, and these small leaks are usually caused by a gas cap, a sticking purge solenoid, or a leaking vent solenoid. Alright guys, so as I'm analyzing the data, I realized that right now I dropped the purge solenoid percentage to 0, and our purge solenoid percent is stuck at 10. Okay, it's supposed to go down to 0, so it's stuck at 10 right now. So it looks like we have a sticking purge solenoid. So you see how it's stuck at 10, and our tank pressure sensor is definitely working because it's reporting vacuum. So right now, as you can see, we have vacuum in the system, and it's depleting it slowly. So it's kind of going up slowly right now. It's going up to atmospheric pressure, and our vent solenoid is not venting, but we're stuck at 10% on the purge solenoid. Okay, so this is supposed to go down to 0 because we're commanding a 0% right now. So I'm going to increase the percentage, the opening percentage. As you can see, so right now we're reading 10. I just increased it to 10%, but our purge solenoid is reading 20%. This is abnormal, guys. So let's go to 20, and here it's going to go up to 30. Okay, something is wrong. And our temperature, our tank pressure is definitely dropping. It's going into a vacuum right now. So let's go down to 0. So we're down with 0. Oh, it kicked us out. So let's exit. So this purge solenoid is definitely sticking. So we're gonna redo the same test again. So let's customize this list. Deselect all. Okay, so right now, as you can see, we still have vacuum in the system because of the test we were doing previously. So it's still depleting this vacuum. Well, the vacuum is kind of trapped right now in the system. And as you can see right now, we're reading 0% on the purge solenoid. Remember before it was stuck at 10. So while we had 0 here, we had 10% on the purge. Okay. So now let's drop this down again. So now I'm going to increase the percentage of the purge solenoid. So right here, as you can see. Okay, so we're going into a vacuum in the tank. So now let's go down to 0. As you can see, now we're down to 0. And we also have 0 here. Okay, so let's go up to 30%. Okay, so for some reason, it's starting to work fine now. Okay, so we have vacuum in the system, and it's definitely depleting slowly. Okay, it's depleting. So basically, this system is not holding vacuum long enough. So since we saw a 10% here that was stuck, so this purge solenoid was stuck at 10%. Now let's go under the hood, and we're gonna use a vacuum gauge. We're gonna disconnect the purge, the EVAP tube from the purge solenoid, and then we're gonna connect a vacuum gauge to it to see if there's vacuum on the other side of the purge solenoid. With the purge solenoid disconnected and the electrical connector disconnected also, we shouldn't see vacuum because this is a normally closed solenoid. We shouldn't see vacuum on the other side of it. So let's go under the hood and check the purge solenoid. I'm sure this will end up being a defective purge solenoid or maybe a gas cap, but I'm most likely betting on this purge solenoid. So let's go under the hood and test the purge solenoid with a vacuum gauge. Alright guys, so we are here under the hood. We're gonna remove this engine cover so that we can get access to the purge valve, and then we will test it while the engine is running. So I'm going to remove this engine cover. So we're gonna get this removed. Alright guys, so here is the purge valve. The purge valve is a normally closed valve. So the computer controls it, it opens it and closes it. So this valve opens to allow fuel vapors coming from the tank to enter inside the intake manifold so that these vapors can be burnt while the engine is running. The computer also opens this valve to allow engine vacuum to enter the EVAP system to test it, okay, to see if the system is sealed. You know, that's how it knows if there's a leak or not. So now what we're going to do is we're going to disconnect this EVAP tube. So once we disconnect this tube from the valve, since it's a normally closed valve, while the engine is running, we shouldn't have vacuum on the other side of the valve, so on this side of the valve. We're also going to do that with the electrical connector disconnected. So now we're going to disconnect this tube so that we can test it. Actually, let me see if I can do that while I'm holding the camera. Oh, there we go. So this is disconnected. We're also going to disconnect the electrical connector because the computer might command this on, and if you do that with the electrical connector connected, it can give you a wrong reading, okay? So we're gonna use this vacuum gauge here to test the EVAP system. I mean the EVAP purge valve. So we're going to connect this hose to this side of the EVAP purge valve. So right here, I'm gonna disconnect the electrical connector. And as you run this with the electrical connector disconnected, it can trigger a trouble code, but that's no big deal. We're gonna erase the trouble code later. So with the engine running on a good valve, we shouldn't see vacuum here, okay? If we see vacuum on the other side of the purge valve, that means the valve is stuck open, then we're gonna replace it. Now, these valves usually stick a little bit. Just by disconnecting it, we can unstick it, and it may not leak right now, because remember when we were looking at the data pads on the scan tool, it was stuck at 10%, and then it went down to 0. So It might be sticking, but the fact that I just wiggled it to remove this EVAP tube, I can unstick it and then it's not gonna leak. So I don't know, we're gonna find out. Hopefully it's bad enough to the point where we're gonna have a vacuum leak on the other side of it. So now I'm gonna go inside the truck and start it. Alright, so I got the engine started. As you can see, the engine is running and we don't have any vacuum on the other side of the purge valve, okay? Because the needle here on the vacuum gauge is showing 0. So there's no vacuum leaking from this purge valve, okay? So the purge valve is basically closed right now, which is normal because it's a normally closed solenoid. So now I'm gonna reconnect the electrical connector. Let's see what's gonna happen while we reconnect the electrical connector. So I reconnected the electrical connector and nothing happened. Okay, so now I'm gonna turn off the truck and then I'll tell you what we're gonna do next. Alright, so as you guys saw, with the engine running, we didn't have vacuum leaking on the other side of the purge valve. So basically right now, with the results that we just got, the purge valve is good, it's not leaking. Now we have to figure out where the small leak is in the EVAP system. So I'm gonna use a smoke machine. We're gonna induce smoke inside the EVAP system so we can pinpoint where the leak is. Now what we're gonna do is we're gonna reconnect this EVAP tube. We're gonna reconnect it to the purge valve. So we got that reconnected. So we're gonna remove this plastic cover here, this plastic cap. There's a little shredder valve in there that we have to remove. So this is the service port of the EVAP system. There's a little shredder valve down in there that we have to remove. So I'm gonna get that removed and then we will connect our scan tool back to the truck. We're gonna close the vent solenoid because you have to induce smoke inside the EVAP system with your vent solenoid closed, because the vent solenoid is normally open. If your vent solenoid is open, all the smoke is just gonna escape out of the vent solenoid. So we're gonna close the vent solenoid. This purge valve is normally closed. So basically the front door and the back door will also be closed. Since the front door and the back door will be closed, the smoke should be trapped inside the EVAP system and the fuel tank. So wherever we can see smoke coming out from, that's where the leak is. So now I'm going to remove this shredder valve. I'm gonna bring up my smoke machine here. We're gonna get it ready so we can send smoke inside the EVAP system. Alright, so I turned on the smoke machine. So now we're ready to induce smoke inside the EVAP system. Before we do that, we're gonna use a scan tool to shut down the vent solenoid first. We're gonna close the vent solenoid with the scan tool and then we will induce smoke inside the EVAP system. So I'm gonna bring you guys over here so I can show you what I'm doing. So we're gonna fix the P0442 trouble code first, and then we will deal with the P0300 afterwards. So let's go to functional test. Let's go to output controls. So we have to look for a directional bidirectional test that tells us that allows us to turn on and off the vent solenoid. So right here, EVAP vent solenoid on and off. So we're gonna click on that. So let's go to continue. Alright, so right now we should be able to close and open the EVAP vent solenoid from the scan tool. So when I click on, you see right here it says venting. Once I click on, it should say not venting, and that would mean the vent solenoid is closed. So these EVAP vent solenoids are pretty loud. Once I close it, I should be able to hear it click. So let's click on. I just heard it click, and as you can see it says not venting. And if I turn it off, it's gonna start venting again. I don't know if you can hear the click. Listen. I don't know if you heard that, but it's definitely closing. So we're gonna close it now. So the vent solenoid has been closed. So now we're gonna turn on our smoke machine and send smoke inside the EVAP system. So we're gonna switch it on. So we should see smoke coming out of here now. And right now there is a pretty much leak tester here. There's a little ball. There's a ball here. So right now this side of the hose is open. So there's a large leak. It's showing a large leak. If I close this, you see the ball will go down to 0. So on a good working EVAP system, this ball, if the system is sealed, this ball will pretty much drop down to 1. Okay, so around 1 here is where we want it. So I can see smoke coming out of this hose. I don't know if you can see, I don't know if the camera can pick that up, but I definitely see smoke right here. So now we're gonna induce smoke in the EVAP system. Alright, so there's smoke now going inside the EVAP system. Since this purge valve is normally closed, we also closed the vent solenoid using the scan tool. So right now the front door and the back door is closed. So this smoke that's being induced inside the system will basically just be trapped in the fuel tank and the rest of the system. So we shouldn't see any leak anywhere. And right now we barely have a leak because right now the ball is dropping. So watch. You see the ball is somewhere down here now. Okay, so basically there's no leak. You know, if I remove, so if I disconnect this hose, so watch, I'm gonna disconnect this hose and the ball is gonna go up. Watch, you see how I'm creating a leak? So I'm creating a leak here. The ball just went up. So as I reconnect this, now watch this ball drop. See how the ball is dropping? So this is good. This is a sign of a sealed EVAP system. This is awesome. Now the question you might have is, if the system is sealed, why is it triggering the P0442 trouble code? Well, remember how this purge solenoid is sticking? So if we have a sticking purge solenoid, like right now, it may not be sticking right now, but if it's sticking momentarily, it's gonna throw that code. And right now, I mean, the EVAP system is sealed because there's no leak. The other thing we can do is we can walk around the vehicle, maybe we can crawl under the vehicle and see if there's a leak. But so knowing that this ball here is going down to 1 here on this graduation, we most likely don't have a leak in this EVAP system. This system is sealed, because if this system was not sealed, this ball wasn't going to drop. And most EVAP systems are not completely sealed to like 0-0. I mean, there will be a slight leak, but that leak has to fall within the threshold of the acceptable leak. So now what we can do is we can go to the gas cap and just watch here. Let's see if there's any leaks here. As you can see, there's no leak. If I open here, we should see smoke coming out of this. Do you see that? Do you hear that? And I'm sure right now we just created a leak. So the ball, you see smoke coming out. So our smoke is getting all the way back here. So let's close this now. So we just created a leak. I know the ball just went up because we removed the fuel cap. So now let's go back to the machine and see if the ball is gonna drop. If the ball drops to 1 again, so that will tell me that we don't have a leak in this EVAP system. Alright, so right here guys, as you can see, here is our ball. The ball is at the 1 mark. Okay, so we don't have a leak in this EVAP system. This EVAP system is sealed. The problem is a purge solenoid or a purge valve that's sticking momentarily. That's the only thing I can think of. Just to be safe, I'm going to, because right now everything seems fine. You know, we just tested the purge valve with a vacuum gauge. There's no leak, and right now it just passed the smoke test. It didn't fail the smoke test. The EVAP system just passed the smoke test. So at this point, I'm gonna go ahead and replace this purge valve. Although it's not leaking right now, I'm sure this purge valve is sticking momentarily, okay? Because right now there isn't a problem, and if I just erase the code and send it out to the customer, I'm sure he's gonna be back here in a couple of days with the same trouble code. And I know that these purge solenoids usually have issues. They work sometimes they stick. So I'm gonna go ahead and get this purge solenoid replaced. And remember, when we were looking at the data feeds, at some point this purge solenoid was stuck at 10%. Our command was at 0, but this purge solenoid was stuck at 10%. So I believe that's why we have the P0442 trouble code, because this purge valve is sticking. Okay, so right there, this is good, guys. So this EVAP system is definitely sealed. So I'm gonna turn off the smoke machine. So let's turn it off. I can just disconnect it. Let's get this thing disconnected. So right there. Now we can open our vent solenoid. Okay, so I mean, you can also close a vent solenoid. If you don't have a scan tool with bidirectional controls, you can close your vent solenoid with vice grips. You just have to find the hose that goes to the vent solenoid and pinch it. If you pinch it, it's not going to allow vacuum or smoke, in this case, to escape from the vent solenoid. And that way you can seal the system and introduce smoke into it to see if there's a leak somewhere in the EVAP system. So in this case, we didn't find a leak. Now what I'm going to do is I'm just going to go ahead and replace this purge valve. Okay, we're going to get this purge valve replaced. Alright guys, so we have determined that the EVAP system doesn't have a leak. The issue is the purge valve. The purge valve seems fine right now, but I'm sure it's sticking. So we're going to replace the purge valve. So that will take care of the P0442 trouble code. So now we're going after the P0300 code. So now we're going to do a relative compression test. I'm doing the relative compression test so I can know. So this will basically give me an idea of how well this engine is running mechanically. I mean, the internals of the engine. So this will give me a pretty clear understanding of how this engine is working internally. So we're gonna use this amp clamp. We're gonna actually set this amp clamp to the 60 amp mark. Okay, and we have to make sure we zero it. Okay, so now we're gonna clamp it around the negative cable of the battery. You can even do that around the positive cable, so it doesn't matter. So we're gonna wrap it so the negative cable of the battery goes down here. So we're just gonna clamp it over here. So right there, we clamped the amp clamp around the negative cable of the battery. So now we're gonna go inside the car because my lab scope is in the car. I'm here by myself. If I had someone, I could have had someone in the driver's seat so they could crank it for me. So we're gonna go inside the vehicle so we can crank it. So let's go inside the vehicle and crank it so we can look at our relative compression waveform. Alright, so we are inside the vehicle right now. We're gonna go to scope multimeter. So we're gonna have to be on the voltage scale. I'm sorry for the glare, guys. So let's go to voltage and let's drop our voltage down to 2 volts, and we're gonna increase our time base. So let's go up to 2 seconds per screen. Let's filter this. Alright, so now I'm gonna crank it, and as I crank it, I'm gonna step all the way on the accelerator pedal. So I'm gonna step all the way down to the floor, and this will put it in clear flight mode as I crank it. So the engine should just crank, it's not gonna start. So now let's crank it. Okay, so let's pause this. Now we're gonna analyze the data. So right here, I mean, this looks really consistent to me, guys. I mean, although there's one or two cylinders. I mean, this one is slightly higher than the rest of them, but this, I mean, across the board, all of them, oops. So across the board, all the peaks and valleys look pretty identical. Okay, so I mean, the engine actually sounds good. Just pay attention to how the engine sounds. Listen. Do you hear that? So the engine sounds good. I don't hear any inconsistency in the way the engine sounds. And this waveform here looks pretty good to me. So we don't have a compression issue. We don't have a weak cylinder. These cylinders look good. We know that cylinder 1 had the most count. So I want to go under the hood and remove the spark plug from cylinder number 1 and look at it. Because this P0300 can be caused by so many things. It can be caused by, you know, low fuel pressure. It can be caused by, partially clogged injectors. There's so many things that can cause this. But I'm going this way because of the data that I looked at when we were looking at the freeze frame data. Because when this P0300 code set, look at the fuel trim numbers. So the fuel trim numbers, so short-term fuel trim number bank 2 and the long-term fuel trim number bank 2. So the short-term and the long-term on bank 2 were normal. So they were within the operating range, okay? Because the operating range on an engine is plus or minus 10%. So the short-term was -3 and the long-term was 4%. So our fuel trim numbers were good. So look at bank 1 now. Bank 1 also. So our trim numbers on bank 2 are also within the normal range. So usually when you have an issue in the fuel system that's causing a misfire, let's say if you have a fuel delivery problem, your fuel trim numbers will be more positive, okay? You have high positive numbers. But if you have a problem in the ignition system, you will have high negative numbers. And as you can see, since our fuel trim numbers are good, we don't have fuel trim numbers that are out of range. I believe the issue is just plugs and wires. I'm sure once we put plugs and wires on this vehicle, this car is going to be fixed. Because if we look at the live data right now, let's look at live data. So let's go to data display. So let's customize this list. Okay, and let's just pick the O2 sensors. And let's look at the fuel trim numbers also. Okay, so that's all I need. O2 sensors and fuel trim numbers. So we're gonna graph the first O2 sensors. Okay, so right here. Fuel trim numbers down here and O2 sensors. So now let's start the vehicle. Okay, so our short-term numbers are counting now. Look at the long-term. So we have 8 on the bank 1 and 9 on bank 2. So right over here we have 1, so 0. So this looks good. Our fuel trim numbers are definitely within spec. Okay, so like I said, if we had a fuel delivery problem, we will have high positive numbers. And if we had an ignition problem or a severe ignition problem, we would have high negative numbers. So these numbers here are definitely within spec. So now let's check the fuel delivery. Let's see if we can drive these O2 sensors rich. So now what I'm going to do is I'm going to give this gas for a couple minutes, and once I let off, we should see a rich mixture here. So I'm gonna let off. Just watch, we should see a rich mixture right here. And as you can see, there is your rich mixture. Here is our rich mixture. So this took a little longer because this is processed data. The computer has to process it and then send the info to the scanner. As you can see, we went rich here and here and over here and over here. So we don't have a fuel delivery problem. This vehicle just needs spark plug and wires. This misfire problem will be solved. Okay, so let's look at our fuel trim numbers one more time. And as you can see here, look at the fuel trim numbers, short term and long term. Okay, so we are definitely within spec. So I'm gonna turn off the car. Let's go under the hood and get these spark plugs and wires replaced. Okay. So I got this spark plug wire removed, and as you can see, the spark plug wire looks old. There's no carbon track there. It definitely looks old. So now we're gonna remove the spark plug itself. Alright, so here comes the spark plug out of cylinder number 1. So right here, I hope you can see it. So this spark plug is definitely worn out. Oh man, look how this spark plug looks. Look at the gap. I hope you can see there's a huge gap here. So the spark plug definitely looks old. The gap is really wide. So this vehicle just needed plugs and wires. So right here, guys, look at the gap on this spark plug. You see how wide this gap is? Yeah, so this is what was causing the misfire, because this spark plug is worn out and the gap is really wide. Okay, so we're gonna put plugs and wires on this vehicle. This vehicle should be running a lot better after we get the plug. I'm gonna bring up a new spark plug here. I will show you the difference of the gap between this one and the new one. So I'll bring up the new spark plug wire so I can show you the comparison. So right here, guys, I hope you can see. Do you see the central electrode? Do you see the difference? You see we don't have a huge gap between the side electrode and the central electrode. Okay, so I'm gonna replace the spark plugs and the spark plug wires. I'm also gonna replace that purge valve. Replacing spark plugs is pretty straightforward and pretty easy to do. I'm gonna get to all of them. I'm gonna replace all 8 spark plugs. I'm gonna replace the wires, and after we do that, we're gonna erase the trouble codes. We're gonna take the vehicle for a spin, and once we come back, I'm sure after doing that, the check engine light will no longer remain on the dashboard. So we're gonna do that, and then I'll come back here so we can wrap up this video after doing our test drive. So I'll get these spark plugs replaced, and then I'll bring you guys back up. Alright guys, so I did replace the purge valve. So right over here, this purge valve is new. As you can see, it looks nice and shiny. So that's a new purge valve right there. I also replaced the spark plugs and the spark plug wires. So these wires are new. I hope you can tell. So right there, the plugs and the wires have been replaced. So now we're gonna go inside the truck and erase the trouble codes. Alright, so we are back in the vehicle. We're gonna erase these trouble codes. Let's see how many trouble codes we have in memory. So we have 3 trouble codes, these P0300, P0442 and P0443. Okay, so this P0443 came on because I disconnected the purge valve while the engine was running. So let's back out of here and erase these trouble codes. So let's go to clear codes. Alright, so let's see if we have any trouble codes in memory. So right there, no codes present. So we're gonna go to Misfire data. So right now, as you can see, there's 00 on the Misfire data. So the history count and the actual count, so all of them are showing 00 right now. So I'm gonna start the engine and let's see if there's cylinders will be counting while the engine is running. So I'm going to start the engine now. There's no count here, so cylinder 2 is not counting, 4 is not, 6 is not, 8 is not counting, so which is good. Let's go to the other bank. Remember, 1 had the most count and they're all not counting, so this is good. But remember, this trouble code set when the engine was at operating temperature, okay? I think it was around 204 degrees Fahrenheit, so we may not be able to see this misfire. What we need to do is we have to test drive the vehicle. We'll come back at the shop and see if there will be any misfire counts on these cylinders. And as you can see, the check engine light is not on the dash, so the check engine light is off. That's good. So one more thing I want to check before we wrap up this video. Let's look at the readiness monitor for the misfire, okay? Let's look at the misfire monitor. If the misfire monitor has run and if it says complete, because the misfire monitor is a continuous monitor, you know, if there's a misfire right now, it would pick it up and flag the code and turn the check engine light on while the engine is running. So let's go back here and let's go to generic, focus. So let's go to generic functions and let's go to readiness monitors. So this is just to double check our repair, okay? So let's see if the misfire monitor has run. So over here we have fuel system test complete, catalyst not complete, EVAP system not complete, so we might have to drive this vehicle a little longer, but we already tested this with the smoke machine, so I feel comfortable. Although the monitor is not run yet, but I feel comfortable giving this vehicle back to the customer with the EVAP system monitor not run yet. And the misfire monitor here says complete, so this is good. If the monitor saw a problem or if it saw a misfire, it would flag the code right now and the check engine light will come back on. So this is good. Let's back out of here. So at this point we just need to go on a test drive the vehicle, and then call the customer so we can give him his car back. So I feel comfortable. I mean, the way this engine runs, it runs better, it sounds better, so this vehicle is fixed. So I'm gonna turn off the engine so we can wrap up this video. So that's it, guys. I'm gonna leave it right over here. This vehicle needed a purge valve, spark plugs, and spark plug wires. So you saw how I was able to know that the vehicle just needed spark plugs and spark plug wires. We looked at the data, we looked at the misfire counters, we looked at the fuel trim numbers on the freeze frame data, and we also looked at the fuel trim numbers while the engine is running. So the fuel trim numbers looked good. So everything else checked out okay. We did a relative compression test. The relative compression test turned out good. The engine runs good. We checked the EVAP system. There's no leak in the EVAP system, but we noticed that the purge valve had been sticking a little bit because at some point it was stuck at 10%. So a sticking purge valve, I mean, this is pretty common on these vehicles. These purge valves usually stick. So a sticking purge valve can cause this. So I'm going to leave it right over here, guys. I hope you liked this video. I hope you learned something. I hope you found this video interesting. If you like this video, give it a thumbs up. If you don't like it, give it a thumb down. But if you do, you gotta tell me why so we can make better videos in the future. If this is your first time here, subscribe to my channel, K Diagnostics. Ring the bell so you can get notified every time I upload a new video. If you have any comments, questions, criticism, leave them in the comment box. Thanks for watching, guys. See you next time.